Hey guys, so I am hoping to start showing your notes to you on some kind of maybe like a Google Classrooms or something, to where if you miss class or you still don't understand, hopefully you can go back to the Google Classroom and check out the video and hopefully help you understand just a little bit more. So this is our first set of notes for when we get back after Christmas break. This is for 4.2, writing equations in point slope form. So I did skip 4.1 because we've already started looking at that. It was just writing equations in slope intercept form. And I just wanted to remind you guys before we went over this today what those looked like. So we've already covered two forms and now we're just working on the third one. There's only three. So the first one we looked at was standard form, and it looks like ax plus by equals c, where a, b, and c were all numbers. So we could have an example of 3x plus 4y equals 12. So when we went to graph that, we need to substitute a 0 in for x. So I had 4y equals 12, so my y-intercept, if I divide both sides by 4, would be 3. And then I would cover up the y to solve for x. So divide both sides by 3, my x-intercept would be 4. So x-intercept would be positive 4. And when you graph that, you have a dot on your y-intercept at 3 and a dot on your x-intercept at 4, and you just connect those two dots there. So we did cover that one pretty in depth, and then we also did this one as well, slope intercept form, and it is y equals mx plus b, where m is your slope and b is the y-intercept. So for example, on this one, we might have y equals negative 3 over 4x plus 3, and when I graph that, the first thing that I'm going to graph is the y-intercept at positive 3, so 1, 2, positive 3. And then I'm, from that point, going to use my slope. So down 3 over 4. So down 3 over 4. And then I can draw my line connecting those two dots. So we've covered both of these before. Now we're going to do this third form, which is point slope form. And it's no different than these pieces right here, where m stood for slope, b stood for y-intercept. All right, sorry I got interrupted there for just a second. So like I was saying, these actually mean something. It's not just gibberish that we want to give you to torture you. So in these examples, our y right here that has nothing attached to it and this x are always going to be y and x. They're never going to change. This piece right here, y1 and x1, those are going to be given points. So I'm going to write that right here, that those are given points. And you guys already know, or you should already know by this point, that m stands for slope. So when we write something in point slope form, that's what we're going to be given, is a point and a slope, and we're going to be able to put that into this equation right here. So it's really not as difficult as it may look just from this gibberish mess right here. So let's look at our first example. This says, write the equation of the line that passes through 2, negative 8, and has a slope of 3/5. So I'm going to go back and use this equation right here, y minus y1 equals m times x minus x1, and I'll just rewrite that here. And I'm just going to substitute in what I know. So I have y minus always stays the same, and my y coordinate is negative 8. And I love this example that that's a negative 8 because we'll talk about this piece right here. So then I'm going to drop down my equal sign. My slope is 3/5. And then in parentheses, x minus, and then my x coordinate is positive 2. So I know that looks kind of goofy having a -2 there when it's a +2, but we're just carrying this piece down just like we did here. Carried down the minus, and then we had a -8 to fill in for y1. So now from here we can simplify this just a little bit. This looks kind of goofy. Now I could have y plus 8 minus a negative is a positive. So I have y plus 8 equals 3/5 times x minus 2. So this is in point slope form, and it's of the line that passes through this point and has that slope right there. So we are all finished. If we wanted to, or if it ever asks you to, we could turn this into slope-intercept form really easily. All we would have to do is isolate y, try to get it all by itself. So if we wanted to do that, we would do distributive property, and then we would subtract 8 from either side. And we'll have some examples like that definitely in class. Another example that we might have is when we're given two different points. So if I need to write point slope form, I need a point and I need the slope. So the only thing that I'm missing here is the slope. So I'm going to find that first using my slope formula. M equals y2 minus y1 over x2 minus x1. And if it helps you, like I know it helps so many of you, you can label these. This is your first coordinate, and that's your x. And this is your y. This is your second coordinate. There's your x, and there's your y. So then we just need to fill in the blanks. So I have y2 is -9 minus y1, which is 7, divided by x2, which is -8, minus x1, which is 4. -9 minus 7 is -16. -8 minus 4 is -12. And then we can simplify both of these things. 4 goes into both of them. And I know a negative over a negative is positive. So if I divide these by 4, I have +4 over +3. So my slope is 4 over 3. Now when I write this in point slope form, I need a point and I need the slope. It doesn't matter which point you use. I like going for the ones that are positive, if at all possible, so that you don't have to deal with something like this. But it doesn't make any bit of a difference. You could do this one as well. So just a reminder, our point slope form, y minus y1 equals m times x minus x1. And then I'm just going to fill in the blanks using this point. That's just the one that I've chosen. 4, 7. So I have y minus 7 equals 4/3 x minus 4. And that is in point slope form. I am all finished. That's the equation. For the last one, it wants us to graph it. And just a reminder, I'm going to write point slope form up at the top one more time. I have y minus y1 equals m times x minus x1. So this right here gives me everything that I need to graph it. It tells me my point and it tells me my slope. The easiest thing to pull out is the slope. It is 2. The next thing I'm going to extract from this right here is the point. So I have my x coordinate and my y coordinate, and I know when I write them I need x and then y, just like the alphabet. So the first one that I'm going to write is this guy right here. Now notice it's a +2, and this says it should be a minus an x. This is the same as this piece right here. So what I really have is a -2. This is really y minus 1 equals 2 times x minus negative 2. See, that double negative makes that positive. So my x coordinate is really negative 2. That's probably the most difficult process about point slope form, is just that little piece right there, knowing that a plus is really a negative. And then for my y coordinate, I have a positive 1. It's y minus, and then whatever your coordinate is, y minus positive 1. So when I graph this, I'm going to start off with my point and then use my slope from there. Just like on here, I started off with my point, or my y-intercept was 0, 3, and then I used my point, or my slope, from that point. So I'm going to put a point at negative 2, 1, negative 2, 1, and then I'm going to use my slope is 2, or as a fraction is 2 over 1. So rise over run, up 2 over 1. And I like to do it a couple of times just to get a nice crisp line. And with your straight edge, so it doesn't get thrown in the garbage can, we need to draw our line, and it has arrows on either end because it never ever ends. Alrighty, so this is the first step of our notes. I hope this helps you out. If you missed, or if you just need that little extra time of writing these down, please come in and tell me if you were able to use this, or if you like doing this. I would love some feedback from you. All right, thanks guys, bye.